Right, okay. Let's see what we need. So today I'm going to start you off on variable acceleration. Can you all just type in the chat box to ensure that everyone can hear me, and can you see a PowerPoint presentation on my screen? Please, thank you. Guys, can you hear what I'm saying? Okay, brilliant. Right, so you can all hear me, you can all see the screen. I'm going to get started in a second. If you have any questions, just type in the chat box and I'll be able to answer them, hopefully. Right, so today we'll be looking at variable acceleration here. This is chapter 11. I'll do this, it should be fairly easy. It's easier than the things that we've done before, I feel. For example, the forces and pulleys and things. Right, so what am I looking for? Yeah, so if we just look at a standard velocity time graph over here, we can see that acceleration has been constant. They've been straight lines in velocity and time graphs, or even in distance, in displacement time graphs as well. And acceleration has been completely horizontal lines. Now what that implies is that acceleration is constant, because the gradient of the velocity graph is your acceleration. We said constant acceleration. If you remember from chapters sort of 9 and 10, we always said constant acceleration. Now what's happening now is we're looking at variable acceleration. So in variable acceleration there is going to be some sort of function, and we're going to be looking at functions instead of looking at graphs which are a combination of straight lines. So let's get started here. So something like this, velocity now might be given to you. Velocity might be given to you in a formula here. So v equals a half t cubed. So this is saying that velocity is given to you in a function of time. As time increases, the velocity is increasing. And you can see from the gradient of this cubic graph that acceleration is increasing as time goes on. So now, mostly with variable acceleration, you're going to be given functions of time, and we're going to use these functions of time to solve like a number of problems. Okay, so let's have a look at some questions. Can everyone hear me okay still? Just type in the chat box to make sure everyone is okay, everyone follows what I'm doing on the screen. You can all see the PowerPoint presentation. Right, where am I? On here. Right, so here we go. Velocity time graph of a body is shown above, where v equals a half t cubed. What is the velocity after 4 seconds, after 4 seconds have elapsed? So saying what is the velocity after 4 seconds have elapsed, and now that simply requires you to substitute in 4 into t, and that will give you v. It's just like saying y equals a half x cubed. Now in this case velocity tells us is v, and t you know is 4, so v is going to be a half times 4 cubed, so 32 meters per second. Now it says how many seconds have elapsed when the velocity of the body is 108 meters per second. So it's saying how many seconds have elapsed when the velocity of the body is 108 meters per second. So if I just switch over to, give me a second, my typing software. Right, so if I just write on here v was equal to a half t cubed, and the question was asking us how many seconds has it been since velocity was 108 meters per second. So I'm going to replace v with 108, and I'm trying to find out what t is. So here I'll multiply the two across, get 216 is equal to t cubed, and therefore if I take the cube root of 216, I'm going to get what t is. Okay, and that should be 6 seconds, and that will give you 6 seconds. Okay, has anyone got Tina, you still can't hear me? Can everyone else hear? It might be the internet connection. Right, okay. Let's have a look, see if I can do anything about this. Right, my microphone says it's active and it's picking up my sound, so I can't. There's a couple of people saying they can hear me, a couple of you that can't hear me. What about now? Yasina and Tina, can you hear me now? Hello, can you hear what I'm saying? Right, okay, that's good. So let me continue on. I'll continue on with the PowerPoint presentation. Okay, so here, as I was saying before, you're going to be given a function in terms of time, and we're going to use these functions to essentially work out whatever we need to work out. Now actually what I should have said earlier, a couple of things. Is if we just look at a sort of displacement time graph up to now, like displacement is given by S, we know that's from Suvat. So we know that from Suvat, and we used to have up to now something like this. Displacement would be something like that, and then the person would come back to wherever they went. Now we had straight lines. Now the gradient here, the gradient on a displacement time graph was velocity. So velocity was equal to the gradient of velocity of displacement. That is what velocity was equal to. So the gradient of the displacement time graph was your velocity, and if I draw a velocity time graph, again, if I look at velocity, it would be something like this. It would travel at constant velocity for a certain period of time, and it might decelerate back again. We would have that acceleration was equal to gradient of the velocity time graph. So just remember these couple of things, and then as we go through it, it's just going to become quite simple, I feel. Right, so going back to this, let's have a look at the next example. So here it goes, a body moves in a straight line such that velocity v meters per second is given by some formula in terms of time. Find the initial velocity is what it's asking for. So for part A, how am I going to find the initial velocity? Can you type into your chat box there, so that I know that you're following what I'm saying? So type into the chat box, how am I going to find the initial velocity given that v is equal to 2t squared minus 16t plus 24? I can't see any. Yeah. So Nibe said, would you make t equal to 0? That's correct. Initial velocity is when time is equal to 0, because initial means when time is equal to 0. So all we need to do to work out initial velocity is to substitute t equals 0 into this, and we get v is equal to 24 meters per second. Okay, now part B. It says the values of t when the body is instantaneously at rest. The values of t when the body is instantaneously at rest. I'm just going to copy this over to my writing software. Give me a second, please, guys. So over here, v was equal to 2t squared minus 16t plus 24, and the question was when the body is instantaneously at rest. Now if it's at rest, what can we say? Can you please type in your answer into the chat box so that I get an idea that you're following what I'm saying? Where would the body be at instantaneous rest? What would the condition be if the body was at rest there? Right, that's good, Mehek. Yeah, velocity is 0. So now all I'm going to do is replace velocity with 0, and I'm going to solve this quadratic, and I'm going to get a couple of values. I'm going to get a couple of values for t. Well, you can now complete that, factorize that quadratic and tell me what you get. Type into chat box once you've answered this question. Right, so you get 2 and 6. Okay, that's good. Let's check the answer. Yeah, at time t equals 2 or time t equals 6, you've got that velocity is 0. The body is at instantaneous rest. Okay, now for part C, it says the value of t when the velocity is 64 meters per second. So it's given you that velocity 64 meters per second, and you need the value of t. Okay, so for this, I'm going to make, so I'll just write over here, part C. 64 is equal to 2t squared minus 16t plus 24. And then if you go about solving this quadratic here, you're going to get the values for t. Again, I want you to solve this and tell me what your t values are in the chat box once you're done, please. Right, has anyone done it yet? I'm waiting for you guys to do it. Right, okay, so Mehek says 10 and minus 2. So that is when the velocity of the object is at 64 meters per second. So here if I just write t equals 10 and t equals minus 2. Now obviously we can't have negative time, so therefore this is not a solution. This is not a solution. The only time when the velocity of the object is 64 is when t equals 10, and this is going to be our only answer. Okay. Right. Now for part D, it's saying the greatest speed of the body in the interval that t lies between 0 and 5. Now, whenever it says greatest, in my mind there is essentially a maximum. The word maximum comes to mind. Now, maximum, we know from your pure stuff, is when the gradient is equal to 0. So here, I know that v is equal to 2t squared minus 16t plus 24. And I want the maximum v. So it starts saying what is the maximum value of y at a particular point if you're looking at pure. But now we're looking at it in the context of this equation that we've been given. So over here, all I'm going to do is differentiate v with respect to t, dv over dt. So I get 4t minus 16. And once I've got this, I can say, well, at the maximum, the gradient is equal to 0. So therefore, 4t minus 16 is going to equal 0. So 4t is equal to 16 and t is going to equal 4. Okay, so t is going to equal 4, and therefore I've found the instant where my maximum velocity occurs, and that is when t equals 4. Actually, I'm just going to check something here. I've just remembered something. If I think about the quadratic graph here, actually, I better do this. This is going to be incorrect. If I look at the quadratic graph, in fact, what I'm going to do, I'm going to sketch it on Desmos. So give me a second. What am I looking for? Desmos. So yeah, sorry, disregard that. That doesn't apply in this case here, because a quadratic is a U-shaped curve, and for me to get a maximum on a U-shaped curve doesn't make sense. So you're going to have to sort of think about what the graph looks like in your interval there. So I'm going to type in y is equal to x to the power of, 2x to the power of 2 minus 16x plus 24. that's what this graph looks like. So now if I just sort of zoom out a little bit, this is what the graph here looks like. Now actually what I'll have found out, when t equals 4, the velocity is at a minimum. That is what I found out, and that's what I realized while I was going through the question. I have to sort of sketch the graph between 0 and 5. If I restrict my graph to be between 0 and 5, I'm only going to be looking at from this point here and all the way along to the top. Okay, when t equals between 0 and 5. Now where's my maximum going to be? It's at the instant where t is equal to 0, because that is the highest velocity in this case for this part of the graph. We can see from t equals 0 onwards, the velocity is going down, 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 and over here it's a minimum at t equals 4, and at t equals 5 it's minus 6. So actually you needed the sketch there, and you need to understand that your velocity is going to be a maximum at t equals 0, and that is 24. So if I go back to this again, yeah, there's your sketch. Oops, so if I go back down, there's your sketch, and it says by inspection the greatest velocity there the greatest velocity there is at 24 meters per second, and that is when t equals 0. Okay, does anyone have any questions? Does that make sense what I've said? Hopefully I haven't confused you too much. Just type in the text box if everything I've said so far makes sense. Or if anyone also has any questions, I can answer them here. Yeah, I'll repeat that again. So what I'm going to do, I'll sketch it, and so hopefully it'll make more sense now. Right, let me just start a new page. I'll write over here d. So velocity was given by 2t squared minus 16t plus 24. Now this I know is a quadratic, and you worked out when velocity was 0, and the graph looks something like this. It's a U-shaped graph because it's a quadratic. Here is the time axis and here is the velocity. At t equals 0 it was 24, and it sort of goes down like that and then comes back up like that. You worked out the two instances where velocity was 0, because there's 0 on the velocity axis. And when was that 0? At 4 and at 6. Sorry, it was at 4 and at 6. Let me just go up. No, it was at 2 and 6. Sorry, not 4 and 6. It was at 2 and 6. And therefore your minimum is going to occur symmetrically between them at 4. That is when your minimum occurred. The question's asking us for what's the maximum velocity between t equals 0 and t equals 5. That's what the question's asking us for. Now looking at this graph, so therefore I only need to consider the graph from here all the way up to here. Those are the only bits of the graph that I'm allowed to look at. Now looking at the graph, I know the maximum v occurs at the point where t equals 0, because that's the highest point on the graph. I essentially need to look for the highest point on the graph, and therefore the highest point on the graph between t equals 0 and t equals 5 is v is equal to 24 meters per second. Okay, so I had to do that by inspection. I couldn't use differentiation just yet, because differentiation actually gives me the minimum velocity, doesn't give me the maximum velocity. I had to do it by inspection. Does that make sense? Yes, you know. Okay, great. So what I would like you to do for homework from this particular bit here is, could you please do 6, 7 and 8, like the exam questions, so that you can get a feel for what kind of questions you have on here for homework. Okay, so 6, 7 and 8 from exercise 11A, and I'm gonna move on to the next part of this presentation. I've got this on video, so you can't say I didn't tell you. Okay, don't try it. Right, okay. So we know that from what I was saying earlier, that the rate of change of displacement is velocity. The gradient of the displacement graph is velocity, and the gradient of the velocity graph is acceleration. So from there we get that over here you can see that I'll have it in a neater format here, so Control M. So if V is going to be equal to d dt of displacement, so if you differentiate displacement, you're going to get velocity, and acceleration is going to be equal to the differentiation of velocity. So the gradient of the velocity time graph gives me acceleration. Okay, now what if I wanted to go back up from acceleration to velocity? I would integrate, and if I wanted displacement, if I wanted s would be the integral of v dt. Okay, so that is what is summarized over here in this little memory tip here. Okay, so if you've got s and you want to find out v, you're going to differentiate. If you want to go from velocity to acceleration, you differentiate again. And if you wanted to go from acceleration to velocity, you'd integrate acceleration. To get from velocity to displacement, you'd integrate velocity. Okay, but right now this particular exercise focuses more on differentiation. Okay, so there we go. So v is equal to ds by dt, and similarly a is going to be dv by dt, or it's also the second differential of displacement over dt, because if I differentiate s to get v and then differentiate again, it's going to be the second differential of displacement. Acceleration is going to be the second differential of displacement. Right, okay. So let's have a look at this question. Particle P is moving on the x-axis. At time t seconds, the displacement is given by some formula. So please note that what it's talking about. You need to understand that this question is talking about displacement to begin with. Displacement x meters is giving us s. Okay, so the displacement is given by this, is saying find the velocity of p when t equals 3. So it's given us displacement, but it wants us to find the velocity of p when t equals 3. I'm just going to copy this into my whiteboard app, and then I'll take it from there. So x is equal to t to the power of 4 minus 32 t to the power of 4 minus 32 t plus 14. I'm just going to double check that. Yep. And for part A, it wants us to find velocity when t equals 3. Now how am I going to get from, I'm just going to put here s for displacement. This is s, it's not anything else. how am I going to find the velocity from my displacement graph here? I want you to have a little think about my previous slide, and I want you to type in the chat box and tell me how I'm going to find out my velocity formula. Any ideas? Yeah, you would differentiate. So to get from S to V, I need to differentiate. So V, sorry, here hopefully, yeah, V is equal to ds by dt. So therefore, my velocity here is going to be equal to 4t cubed minus 32, and that's it. And that's my velocity formula. And I need to find v when t equals 3, so all I'm going to do is substitute t equals 3 into this equation. So I'm going to do 4 times by 3 cubed minus 32. 3 cubed is 27, so times by 4 is 108. 108 minus 32, I don't know what that is. Oh yeah, sorry. 10 minus 7, 76, something like that. 76 meters per second. That is my velocity. Okay. So, and there we go. Now, it's saying for part B, the value of t when p is instantaneously at rest. Now again, we need to put it in the context of this question. When p is instantaneously at rest, so when it's at rest for part B, I'll write down, well, if it's at rest, v must be equal to 0. So that then implies that 4t cubed minus 32 is going to be equal to 0. 4t cubed is equal to 32. T cubed is equal to 8, implying t is equal to 2. And that is the instant when the object is instantaneously at rest, when t equals 2. Okay. Now, for part C, it wants the acceleration of p when t equals 1.5. Okay, so we've been asked to work out, I'm just going to write here, acceleration equals question mark. So how am I going to get acceleration from my velocity? Well, again, we know that acceleration was equal to dv by dt. That is what acceleration was equal to. So if I just extend this page one more time, yeah. So acceleration therefore is going to be equal to d dt of 4t cubed minus 32, because that was our formula for v. V was equal to 4t cubed minus 32, and therefore if I differentiate this expression here, I'm going to get 12t squared. So acceleration is 12t squared. And then I wanted acceleration when t was equal to 1.5. So I do a is equal to 12 times by 1.5 all squared. And that is whatever that is. I should be better prepared for next time with a calculator. Left mine at school, sorry. And there we go, it's 27 meters per second squared. Okay, does anyone have any questions at this stage? Please type into the chat box. Again, also, if you need me to unmute you so that you can speak and ask me a question, I can also do that as well. So please let me know if anyone has any questions, and I'll do that. Otherwise, let's move on. Right, okay. So, what do we have here? We've got a cat's displacement from a house in meters is that, and it's asked us to work out a number of questions. What I would like you to do, I'd like you to do this by yourself now. Having gone through the previous example, do this yourself now, and once you're done, I'll give you a minute or so, and then I'll expect you to give me answers in a bit. Okay, so don't type in your answers yet and spoil it for everyone else. Just do it yourself for A, B, and C, and I'll ask you questions in a bit. I'm going to ask one of you specifically to tell me what the answer is, so you better be doing it. Right, okay, so let's have a look at the first part A. Determine the velocity. So again, I'm going to switch over. Right, Mehek and eBay and Yasin have spoken in there. Someone else told me what the answer to part A is. Marvin, what'd you get? Alright, okay, so let's check if that's correct. So I'm just going to write this formula out. So again, S is the displacement is equal to t cubed minus 3 over 2t squared, t cubed minus 3 over 2t squared plus 36t plus 36t. So to get from here to the velocity, I would differentiate it. So v is equal to ds by dt. So therefore v is equal to 3t squared 3t squared, and if I multiply the second thing by 2, I'm going to get minus 3t plus 36, and I wanted the velocity equals question mark when t equals a particular value, and that was 2. So when t equals 2, so therefore all I'm going to do is substitute t equals 2 in there, so v equals 3 times by 2 squared minus 3 times by 2 plus 36, and that then gives me, so what is this? Have I done something wrong? I'm just going to check. Plus 36t, when I differentiate that, yeah, I'm going to get this. So here 2 squared is 4 times 3 is 12. 12 minus 6 plus 36. So here I get 6 plus 36 is 42 meters per second. Marvin, he says 6. Let's see. Yeah, it should be 46 meters per second. Can you understand does anyone have a question why 42 is the right answer? If you have a question, either type in the chat box or message me in the chat box and I'll unmute your mic. Right, for part B, it says, at what time will the cat be instantaneously at rest? So, for the cat to be instantaneously at rest, that is when v equals 0. So now, the condition that I have for part B is that v equals 0 and t equals question mark. So all I'm going to do is write down 3t squared minus 3t plus 36 is equal to 0, and from here I'll factorize the 3 out, so I've got t squared minus t plus 12 equals 0. If I factorize this, so I get t minus 4 t plus 3 equals 0, and so I'm going to get t equals 4 or t equals minus 3. Now I can't have negative time, so this is not a solution, so this is the correct solution. T must be equal to 4. Now for part C, the question is asking us what is the cat's acceleration after 5 seconds. So now for part C, I need to work out, I'm going to extend the page again, give me a second. Right, I need to work out acceleration of the cat after 5 seconds when t equals 5. Now for me to be able to do that, I first of all need the formula for acceleration, and I know that acceleration is dv over dt. So therefore acceleration is going to be the differential d dt of 3t squared minus 3t plus 36. So when I differentiate this expression, I'm going to get 6t minus 3. Now that is my acceleration. The formula, the general formula for acceleration, but I need to find out acceleration when t equals 5. So my acceleration is going to equal 6 times by 5 minus 3, and that is 27 meters per second squared. Okay, hopefully that's the right answer. Okay. Has anyone got any questions that they'd like me to go over in understanding any of these parts here? Type yes in the chat box if you understand everything I've done, please. Okay, yeah, I'll go over B and C, Anamika. So for B, it's saying at what time will the cat be instantaneously at rest? So I'll just do a new page. So for B, cat is at instantaneous rest. Instantaneous rest, oh, my spelling's poor, so please forgive it. Cat is at instantaneous rest. That implies that velocity must be equal to 0, because if it's at rest, that means it's not moving. If it's not moving, that implies velocity must be equal to 0. So we need to find the time when velocity is 0. I already know the formula for velocity. Velocity was equal to 3t squared minus 3t plus 36. So therefore I want 0 is equal to 3t squared minus 3t plus 36, and when I solve that quadratic, I get t equals 4 or t equals minus 3. I get t equals 4 or t equals minus 3. Now obviously time can't be negative, so therefore t equals 4 is the only solution. Does that make sense, Anamika? For part B. Okay, that's good. Now let's have a look at part C. Part C, the question was asking us, what is the cat's acceleration after 5 seconds? So to find out the cat's acceleration after 5 seconds, I'm going to need to find out a equals question mark when t was equal to 5. So far I know that v is equal to 3t squared minus 3t plus 36. How am I going to get the acceleration from here? Well, acceleration is the differentiation of v from the first slide for this exercise. So if I differentiate this, I get 6t minus 6t minus 3, and there's my acceleration. I've got a formula for acceleration in terms of t, and all I need to do is substitute t equals 5 in there. So a is going to equal 6 times by 5 minus 3. So a is equal to 30 minus 3 is 27 meters per second squared. Okay. Has anyone got a question here? Does that make sense now, Namika? Are you happy with that? Right, okay. That's brilliant. Let's move on. So, for the next exercise, what I want you to do is 11b. Let me just scroll through again. I think there's only really value in doing like exam style questions, so if you could please have a go at, once this refreshes, 11b 4, 5 and 6 please. Okay, 11b 4, 5 and 6. Right, let's move on with our presentation. Right, this is the bit I jumped to earlier on. Right, maximum minimum points happen when the gradient is 0. So if it wanted maximum velocity or maximum acceleration or anything like that, you've got to refer back to gradient being equal to 0. That is the key bit of learning here. Okay. Right, so let's go through this example here and understand what we've been asked to work out. So, child is playing with a yo-yo. The yo-yo leaves the child's hand at time t equals 0, travels vertically in a straight line before returning to the child's hand. How yo-yo generally works, unless you're really poor at playing with a yo-yo. The distance s meters of the yo-yo from the child's hand after time t seconds is given by that. Okay, it's given by that, and t lies between 0 and 3. Right, justify the restriction that time must lie between 0 and 3. Well, a yo-yo is going to go down and come back up within 3 seconds. A yo-yo is not, unless you're really bad at playing with a yo-yo, is the displacement is not going to be down at like the floor level for a very long period of time. A yo-yo is only going to be going down and staying down for a little bit of time and then come straight back up. Okay, so therefore we need to put a restriction on time. this is talking about it from the point of view of the graph. It's a cubic, and over here we can see that your displacement is between zero. Essentially, you're looking at your displacement can't be negative. It won't go back higher than where it started. So for your displacement to be relevant, you're only looking at this top part of the cubic curve, the top part of the cubic curve, and that has roots of 0 and 3. How would you have got this? You would have had to get your roots from your calculator by solving this cubic. You would have got your three roots: t equals 0, t equals 3, and t equals -1. And then when you sketch it, you'd understand that for displacement to make any sense, it would have to be non-negative, because your yo-yo is not going to go up higher than where you start off, and for that to be true, your time must lie between 0 and 3. Now for part B, it's saying the maximum distance of the yo-yo from the child's hand. The maximum distance of the yo-yo from the child's hand correct to 3SF. So what we've been asked to work out for part B is maximum distance. Maximum distance then implies gradient of S must be equal to 0, because maximum implies, this implies ds over dt must be equal to 0. Even if it said minimum, it would be ds over dt is equal to 0, and I know the formula for S is given by 0.6 t 0.4 t squared minus 0.2 t cubed. 0.2 t cubed. Now I want the maximum distance, and at the maximum distance the gradient of this curve ds by dt must be equal to 0. So I'm going to differentiate this. ds over dt is equal to 0.6 plus 0.8 t minus 0.6 t squared. Right, okay. Again, I don't have a calculator, so you're going to have to solve that quadratic. Well, firstly, you're not going to have to solve that quadratic. You're going to make this gradient equal to 0. So 0 is equal to 0.6 plus 0.8 t minus 0.6 t squared. And now you solve this quadratic, and once you've done that, please give me your t values in the chat box. Again, if there are any questions, please type in the chat box if anything that I've said so far doesn't make sense. Right, again, this lesson is recorded. It's going to be a long YouTube video. So I'll put it up on YouTube hopefully by the end of the day today, so that those of you that joined late can catch up on the earlier bits, and those of you that didn't bother joining in can check it. Right, okay, I'm still waiting for the answers to this quadratic in the chat box. Right, so t, and what was your other solution? T equals 1.87, and because it's a quadratic, you would have probably got two solutions unless it's exactly the same. Oh, this is, yeah, and t equals minus 0.534. So over here we can see that time can't be negative, so this is not a solution. So t equals 1.87 is the instant where your gradient is 0, but we've not found the maximum distance yet. We've just found the time when the when s is at a maximum. So therefore I now need to substitute this back into s. So s is equal to 0.6 times by 1.87 plus 0.4 times by 1.87 squared minus 0.2 times by 1.87 all cubed, because I actually wanted the maximum distance. All I've found from doing this quadratic is the times when it is at a maximum. To find the actual maximum distance, I'll need to substitute that t back into the expression for s and get some value. Okay, so if I go back to this, yeah, and there we go, and you get 1.21 meters. That is the maximum distance. So when the yo-yo is hovering at the bottom for like that small amount of time, that is 1.21 meters away from where the yo-yo started off at waist height. Okay, does anyone have any questions in there? Would anyone like me to go through anything again? Please type in the chat box if you have any questions, otherwise I'm ready to move on. Right, okay. Right, let's have a look at this question here, just to sort of recap everything in this particular exercise's work. Dolphin escapes seabird, and its velocity as it speeds away from the park is given by this expression until it reaches maximum velocity, and then subsequently remains at this velocity. When does the dolphin reach maximum velocity? What is this maximum velocity? Okay, so in this case, let's get started. So in this case, we've not been given s, we've been given v, because it says velocity is given by some function of time. So here I'm going to have t cubed minus 9t squared 48t 500. T cubed minus 9t squared minus 48t plus 500, and that is our velocity formula, and I need to find, for part A, I need to find t equals question mark at maximum velocity. So I need to find the t when we're at maximum velocity. How am I going to do this? For me to be able to do this, maximum velocity then implies that dv over dt is equal to 0. if dv over dt is equal to 0, then that means I need to find an expression for dv over dt. So I'm going to go ahead and differentiate there. dv over dt is going to become 3t squared minus 18t minus 48, and now I'm going to have to make that equal to 0 and find the t value. So 3t squared minus 18t minus 48 is equal to 0. That becomes t squared minus 6t minus 16 is equal to 0. So I get t minus 8 and t plus 2 is equal to 0, and that then tells me that t is equal to 8 seconds. So at time t equals 8 seconds, the velocity is at a maximum. Now part B of that question said, what is this velocity? What is the maximum velocity? Well, the maximum velocity therefore is going to be when t equals 8. So I know the formula for v. V equals is going to be t cubed 8 cubed minus 9 times by 8 minus 48 times by 8 plus 500. Right, and whatever that comes out to. So here we go, t equals 8, and finally if you substitute that time in there, you get 52 meters per second squared. Okay, does anyone have any questions here? Would anyone like me to explain anything again to you here? Please type in the chat box. Right, you can have a look at this question here if you like. I'm just going to go over to the exercise. I don't know why it's playing up here. Probably because of bandwidth. Right, for the next exercise 11C, could you please do 4, 5 and 6 for homework? So for 11C, could you please do 4, 5 and 6 for homework? I'll call that a lesson now, and what I'm going to do, I'll have another lesson next week on I need to figure out a time. I'll email you. Hopefully I'll try getting it done as soon in the week as possible, so hopefully Monday. Yeah, I'm going to fix Monday, so you've got enough time between now and then to do the homework. Ask me any questions if you have in the meantime, or like whatever problems you have with your homework, I can go over that, and then I'll finish off chapter 11 on Monday. Right, okay. L1, I'm guessing that's Liam. 3 at the dogs. What's that? What was the homework for 11A? Right, okay. Let me just check. 11A. 11A was 6, 7 and 8. Um, 11B was 4, 5, 6, and 11C is 4, 5 and 6 as well. Okay, so make sure you do these questions by Monday, so that if you have any problems, I can look this up and I can help you in your session. Okay. Hopefully this has been useful. Hopefully you've understood it. Again, it's recorded for you. I'll upload the video by tonight and send you out a link. And yeah, so 11C 4, 5 and 6, 11B 4, 5 and 6, and 11A 6, 7 and 8. Hopefully you got that all this time, Anamika. Right, thank you and goodbye.